Okay girls, so today we are looking at simply the double replacement component of replacement reactions. So this is commonly referred to as a precipitation reaction, and what we're doing is we're taking two aqueous ionic substances, mixing them, creating two new ionic substances, and occasionally one of those ionic substances won't be soluble. Okay, so it won't be able to dissolve in the water that's our solvent, and it will appear as a solid. Alright, for the most part at the moment, all I want you to be able to do is predict what your products are going to be. So we'll have a bit of an overview of these types of reactions, and then we'll look at a few examples. So the first thing we really want to do is just get a bit of a feel for what's happening in these reactions. So with a double replacement, what we're going to say is that we've got two reactants, okay, they're both ionic substances, and we're going to sort of try and break them up into components. So let's say my first ionic substance is going to be made out of a cation A and an anion B. And we're going to react that with a second ionic substance. In this case, the cation will be C, and the anion will be D. Okay? Now, what's going to happen with this reaction is our anions and cations are going to swap which pairing they actually have. Okay, now normally I'd do this horizontally, but just the way it's set up. So what's going to happen is A and B are effectively going to swap. So A is going to come across and match up with D, and B is going to come across and form a new substance with C. Okay, so what we're doing is we're literally just taking, think about it like being Lego bricks. You're pulling those bricks apart and just putting them with the other one. Okay, so when we look at our product for this, what we're going to end up with, we'll have A, but our product is going to have A paired up with the anion D from over here. Okay. We'll then have a second product, which is going to pair up my second cation. So in this case, that was C. And that will pair up with my anion from my first substance, which is B. So, like I said, we've literally just swapped around our anions and cations like bricks. We pulled them apart, rearranged them, put them with the other one. So that's the basis of how this works. So what does this actually look like in practice? Well, let's start off by looking at some worded equations, and then we'll bring our chemical equations into it. So here I've got a couple of problems, we'll work through these. So solutions of iron sulfate and barium hydroxide are mixed. Now, how do I know that this is a double replacement or a precipitate reaction? Well, what I'm looking at is the information in the question. Like, it's telling me I've got two solutions, so solutions of, and then I know these are ionic substances because iron is a metal, sulfate's a non-metal, barium's a metal, hydroxide's a non-metal. So I know they're ionic substances. So that's how you tell. Okay, if you're reading the question, solutions tells you that you're mixing two solutions, and then you look at what the chemicals are. If it's a metal and non-metal, or metal and a polyatomic anion, then you're going to have a precipitate reaction. So start off by writing out a bit of a word equation of what's actually going on. So I've got iron 2 sulfate. I'm going to react that with my barium hydroxide. Now, in terms of the products that I'm going to get, I can predict these just by the names. So my iron iron 2 is going to go with my hydroxide. So I'll try and write it a little bit neater for you. And my barium is going to go with my sulfate. So I've predicted my my products. Okay. Now what I need to do is get these into a chemical equation, a balanced chemical equation. So I'm going to work my way through it, and then I'll sort of leave you guys to have a bit of a practice of the second one. So iron 2 sulfate. Let me just give myself a little bit more room here, guys. Okay. Iron 2 sulfate. So it's Fe, and I know it's a 2 plus because it's iron 2. It's with an SO4 group, and that's a -2 charge. So using my crossover method, I've got my 2, I've got my 2, 2 to 2, get that to your simplest ratio, so a 1 to 1. So my first formula is FeSO4. That's reacting with barium hydroxide. So barium plus 2, OH is a -1. Crossover method brings it to a 1 to 2, so I'm going to have BaOH, and because it's a group, I need that in brackets with a 2. So that's my first part of it. They're my reactants. Now I need to do my products. So I've got iron hydroxide. So Fe's got a +2 charge, OH's got a -1. I can basically tell from that I'm going to need 1 Fe and 2 OHs. So my first product, iron hydroxide, is FeOH2. And then barium sulfate, it's a +2 charge, sulfate's a -2 charge, so that's just going to be BaSO4. So now I've got my formulas for my products. Okay, I then need to balance it. Alright, so you should know how to do your balancing at this stage. Go through, start off with your groups. So I've got 1 SO4, 1 SO4, sweet, 2 OHs, 2 OHs, even better, 1 Fe, 1 Fe, 1 Ba, 1 Ba. It's already balanced for you. Okay, if it wasn't balanced, you'd have to put your numbers in accordingly. But it's a little bit of a process. So start out putting in your word equation and predict your products. Next, find your ions for your reactants. Okay, so I found Fe2, I found SO4, crossover method, get my formula, Ba +2, OH -1, do your formula. Then FeOH2, okay, so my Fe, my OH came together, BaSO4, and then go through and balance. Alright? We'll do this second example, and then you've got the worksheet on Canvas that you're going to be able to go and have a bit of a play with. So, solutions of calcium nitrate and sodium chloride. So, calcium nitrate plus sodium chloride. And that's going to go and form. So swap your metals over. You're going to have sodium going with nitrate. So sodium nitrate's first one. And then calcium chloride as your second product. Cool. Now, get your formulas. So calcium nitrate. Ca is a +2, nitrate NO3 is a -1. Crossover method, 2 of those, 1 of those. So my formula for calcium nitrate is going to be Ca NO3, and I need 2 of those. I'm then going to react that with sodium chloride. Now that one, I don't even need to play around with. I know that's NaCl. Alright, so if you know stuff, just do it. Then that's going to form calcium chloride. So Ca is a +2, Cl is a -1, which is a 1 to 2, so CaCl2, plus calcium chloride, which is what I just did, sorry. Sodium nitrate is Na plus 1, NO3 minus 1. So you can pretty much figure out that that's going to be NO3. And then we just need to go through and make sure that we've got this balanced. So if I have a look, scroll down. So if I have a look over here, I've got NO3, I've got 2 of them. I've got 1 of them over here, so I'm going to need 2 out the front. Chlorines, I've got 2 of them here. I've got 1 over here, so I'll put 2 out the front. 1 calcium, 2 sodiums, 2 sodiums. That's figured itself out. Okay, so go through and try the worded ones first from that sheet. Once you've gone through the worded questions, you will get some that start off, will give you chemical formulas like these. Okay, start off and do up a worded equation. Okay, so you've got potassium hydroxide and lead nitrate. You've got sodium carbonate and you've got calcium sulfide. All right, do up a worded equation, figure out what your products are going to be. Then work your way through, figure out your formulas, get your formulas, balance it out. Okay, we'll practice these in class, but you can practice a few of them now that we've just gone through. That'd be great. All right, thanks guys.